Okay, thank you very much for the introduction. Good morning, everyone, to this webinar. I'm very pleased to present here. So this talk will be about the perception of passenger comfort, really, in future vehicles, which will be hopefully shared and automated, and particularly we'll be focusing on the HMI design. But before I do, I'd like to include a little bit of entertainment. I'd like to show you a little video, which I think might be appropriate given the series of this webinar. For those who have seen it, please enjoy it again. For those who haven't seen it, have fun.
Good morning, Eric.
Yes, good morning. Let's go.
What is your destination today, Eric?
Destination is work, just like every day. Go, start driving.
Would you prefer the standard way?
No, I prefer you take me through China.
China is 15,000 miles from here. Loading maps and alternative language.
No, abort.
A boarding trip to work. What is your destination today, Eric?
As I am begging you, just take me to work.
Engaging climate control system.
No, enough with the climate control. Just drive.
Sensing nerves level rising. Activating relaxation music.
No, I just want to drive.
It might be your last chance to drive. Alfa Romeo Giulia, עכשיו בישראל.
Eric.
זה שאתה נושם, לא אומר שאתה חי.
So I hope you enjoy that. I have to say from now on will be less entertaining than that, but anyway. Right, so my talk is about passenger comfort experience, and as you all probably know, if we look into the future, we see two major trends that will have a big impact on the occupants. Of course, there's the automation on one side, and the other side is the shared economy and the shared mobility, and a very big impact it will have on the way we design. So whereas currently everything is designed around the driver, in the future, whether it's going to be autonomous or shared, or ideally a combination of these two, the fact is we all become passengers. Of course, that will make a big difference in terms of how we design the vehicles, how we design the interactions, but also how we have to think about the HMI, the human-machine interactions that take place in these future vehicles. So from a customer point of view, from a user point of view, you can argue that in the future, the ability to do something other than driving will be the biggest benefit of these future vehicles. And the argument that's made here is that the ability to do so in comfort is actually far from trivial. So there's a lot of challenges that make it quite difficult to actually enjoy or use your time more productively in these future vehicles. So really the key points that I want to talk about in this presentation is that passenger comfort will become the key user requirement, but also the commercial differentiator in future vehicles. So this talk is focusing around the topic of why comfort is actually non-trivial going forward in the future, what we mean by comfort, what factors have an impact on comfort, and finally, what does it mean for the design of the HMI? So I will discuss these largely sequentially, but there may be some sort of overlap and interactions. So what we've seen so far is that the future vehicle is envisioned as a living room on wheels. I've seen many examples of that. In fact, a couple of weeks ago we had the degree show here at the Royal College of Art, where of course automated and shared vehicles also featured heavily amongst our students, and of course just to get a bit of an impression. These sort of the things here. We see an example of a shared car for people who don't want to share. We have high-speed shuttles that travel on the roads that allow you to drive, to allow you to work for long durations in large vehicles. Here we even have a vehicle that includes a bookcase that allows you to read in the vehicle, etc. So we see sort of these sort of similar trends occurring where the vehicle is being considered as a living room, as a space where we can work. And the same is true for the different design studios, the different OEMs going forward with some of the concepts for the future vehicles. And if we look at them, they actually cover quite a lot of similarities in terms of what they actually offer. So we see a lot of rearward-facing seating arrangements. We see that the outside view tends to be very often limited. They tend to be limited by the use of displays in the vehicle or by the actual interior design of the vehicle itself. We see a lot of displays and they tend to be very large. They also tend to be located in positions that are actually quite hard to operate. And so we see quite a lot of sort of awkward positions related to the use of these HMIs. Another thing that probably hasn't received that much attention is the fact that a lot of the emphasis is on the consumption of content, but actually, if we think about a future where we use the time more productively and actually create content, then that's quite a different ball game. It's actually very difficult to create a comfortable and usable environment that allows you to create content. So if we sort of scratch a little bit under the surface of these concepts that we see, we can ask ourselves all sorts of questions in terms of, are these concepts really safe? Are they usable? Would they be really productive? Of course, the topic of today is, are they actually comfortable? And are they actually really well designed for people? And of course, I fully acknowledge that these are concepts. Concepts are meant to stimulate discussions. And in fact, particularly from a human factors point of view, I think these concepts are actually really useful to point out some of the discussions that we probably need to have around how these future interactions will look like. Sometimes these concepts may come across relatively naive, but at the same time, they are thought-provoking, and they allow us to think about how the actual future might look like. So if we think about future vehicles, I don't think we can think of them as living rooms, offices, and entertainment venues and wheels. The main reason for that is that ensuring that people enjoy these sort of new experiences and comfort is actually very difficult to achieve. So if you think about the main factors that will challenge the future passenger comfort experience, I think there are probably at least 4 factors. The very first one is a very obvious one, which is inherent to both the shared mobility and automated vehicles, is that of course we're no longer in control of the vehicle. Now, this loss of control will have psychological effects, and a lot of research and effort is going into understanding aspects of trust in the system. But there's also other aspects that relate to the physical comfort of people within the car. We no longer can hold on to the steering wheel, which has an impact on how we move around in the vehicle. And as we'll show later on as well, there's also physiological effects of actually not being in control, and I'll come back to that later on. A second major factor is the coexistence of automated, shared, and conventional vehicles. It's widely expected that we will see a mix of different vehicles together on the roads, and that means that a lot of the requirements for future vehicles will actually be very, very similar to the ones that we see now in terms of, for example, the safety. But it also means that from a physical perspective, but also psychological perspective, is that we have to deal with these conventional vehicles. So in terms of the perception of safety, there is still the sense that there is a risk being on the road, even though you have a very safe automated vehicle. Secondly, we cannot control the traffic flow completely, so we are still bound by current traffic flow and current vehicle dynamics. So the vehicle dynamics of these future vehicles are probably also going to be very similar to the current ones, at least for now. And that brings me to a third point, which is that we have to design for a moving environment. As I mentioned before, we'll have a lot of start-stop traffic, we have a lot of cornering, roundabouts, etc. So this is a reason why designing the vehicle as it is a stationary office may not be the most appropriate way of looking at it. And finally, I think this is quite an important one, is that a big challenge as well are the user expectations of these future vehicles. I think this is now sort of coming back to us a little bit, in that the expectations that are being raised in the media, but also by the OEMs about the future of automation. We can now see that these sort of timelines are sort of starting to be expanded into the future, and that we probably may not quite get what we're currently being promised. And this is quite important because obviously the acceptance and uptake of these future vehicles will very much depend on people's expectations. Okay, so we talked a little bit about passenger comfort and why I think it's non-trivial to achieve. What I'd like to do now is very briefly is to talk a little bit about what we actually mean by comfort, what comfort is, and look at some of sort of the underlying factors that may cause comfort or discomfort. Okay, so here we see a quite widely held and used definition of comfort. A multifaceted experience influenced by a combination of physical, psychological, semantic, and social variables. And as you can see, there's a lot in here, which is why comfort is sometimes considered a beast of a phenomenon, in that it's very hard to put your finger on. It's a very complicated and complex experience, and for that reason, very hard to design for as well. So if we think about it as lying on a scale from discomfort to comfort, we can look at the discomfort as a state where one experiences hardship of some sort, which could be physical, physiological, or psychological. And then comfort, on the other hand, would be a pleasant state of well-being, ease, and physical, physiological, and psychological harmony between the person and the environment. Now, within the academic literature, there's a lot of discussion as to whether comfort and discomfort are actually concepts that should be on a single scale, or whether they're actually completely qualitatively different experiences. For the sake of arguments, we here look at it as a sort of a sliding scale, going from discomfort, neutral position, to comfortable experience. Another thing to mention, of course, that comfort is a time-related experience, so it changes over time. And it changes also across different experiences. Another thing probably to mention is that very traditionally, particularly in the automotive industry, a lot of attention has been paid to avoiding discomfort rather than optimizing and creating comfort. And I think, coming back to the user expectations in future vehicles, I think what we probably need to move towards is to absolutely ensure that people don't experience any discomfort, but we really have to make sure that people create added value of these future vehicles and create very comfortable experiences, which again will be very challenging. So if we dive into a little bit more detail about the experience of comfort, you can here see a relatively simple model of the way comfort is being constructed. So at the top we can see there's an interaction between the passenger and the vehicle. That leads to a sensation. The sensation is interpreted by our brain. That leads to perception, and ultimately that leads to an appreciation of the perception, which then results in either a negative, a neutral, or a positive evaluation of our comfort levels. So if we add a bit more detail as to what are some of the factors that we might want to consider that may have an impact on our perception of comfort. Starting out with the passenger, there will be elements like age, gender, experience, and the level of trust people have in systems, for example, as a dispositional characteristics of people. There's of course the vehicle, so there's the interior, the exterior design, the user interactions, configurability of the interior, and perhaps the personalization or adaptability of the environment, and the HMI will all play have an impact on the interaction between the passenger and the vehicle. There's also other things to consider in terms of the journey conditions. So what are the vehicle dynamics that are related, that are sort of caused by the traffic flow and traffic characteristics? So that's related to the traffic density, the traffic mix, but also the time of day. So traveling, for example, at night may create a completely different experience and associated comfort experience compared to traveling by day. And similarly, weather conditions will also have an impact on how comfortable people may feel within a future vehicle. We can also see that there's a few moderating factors on the bottom right there. So, for example, attention will have an impact on how we perceive our environment. So if we're engaging in non-driving tasks, our attention may be diverted to other things, and we may pay less attention to our perception of comfort. Our memory of comfort is also a very important aspect that we have to take into account. So that might be related to our previous travel experience on other modes of transport, like public transport, normal vehicles, or in fact competitor AVs as an example. And there's also expectations, as I mentioned before. So the brand will have an impact on how we appreciate the comfort that we perceive. The media, so our sort of view of what we expect from these future vehicles will have an impact. And finally, of course, our emotion is a moderating factor that will have an impact on our comfort. So these might be more sort of personal trait characteristics and stable characteristics like mood, but also the current emotional state. Perhaps also things like traveling goals as to why are we traveling, are we in a hurry, etc. So as you can see here, there's quite a few elements involved in the perception of comfort. And of course, a lot of these have implications for the HMI. I won't have the time today in this seminar to talk in a lot of detail about all these different associations with the HMI, and we'll have to focus on a few smaller things. But coming back to where we currently are and where we're going, I think from the very beginning of the automobile, we have very much focused on the driver from a design perspective. Even though from the very beginning we also had passengers, the passenger experience has always been second to that of the driver. And as a consequence, we also know relatively little about the passenger experience compared to the driver experience. And of course, that's very different if we look at different modes of transport. So, for example, if we look at the aviation industry, the aviation industry has a strong interest, obviously, in the passenger experience because they are their only customers. And so, for example, if we look at some of the by now quite old statistics, but it gives you some sense of how important the passenger experience is that more than a third of flights are based on the comfort of the airline rather than the flight schedules. So, of course, for this industry, it's becoming extremely important to understand what are the factors that are associated with passenger comfort. And fairly recently, some fairly large-scale work has been done to try to establish what are these main factors that have an impact on people's perception of comfort. And what you can see here is the results of large surveys that was conducted with air traffickers, sort of passengers. And basically what you see here are 8 factors that have been shown to have an impact on the passenger experience. So there's physical well-being, peace of mind, proxemics, pleasure, satisfaction, association, aesthetics, and social aspects. So I'll come back to those in more detail later on. So these are factors that were considered of importance for the passenger experience in aviation. But of course, if we want to understand what this could mean and how we could use these sort of findings in the context of road vehicles, it's important to keep in mind that there's a few differences, obviously, between traveling in an aircraft versus the road. A very important thing that I've briefly mentioned already is that the motion profiles are completely different, and as we will see later on, this is actually a very defining element and defining factor in the design of these future vehicles. So whereas in public transport and aviation, we tend to travel long distances at relatively constant velocity, we don't actually sense that we're actually moving. And this is very different to road traffic, where we have a lot of varying velocities in terms of stop-start traffic, cornering, etc. So we're always being sort of thrown around in the vehicle to some extent. There's sort of obvious differences. The aviation industry is extremely low risk. The chances of an accident are extremely low. This is very different in the road environment, of course, where every single second and millisecond counts when it comes to road safety. In aviation, the passenger has, by definition, no control. In the future, we may have control depending on the level of automation, and this will again have an impact on our perception of comfort. In the aviation industry, we are being flown around or driven around by professionals. In future vehicles on the road, we still have probably conventional vehicles on the road as well. So again, the environment is very different, and this also means that the comfort model that we previously seen for the aviation industry may not be completely comparable to or useful for road vehicles. So this part of the work that we've been trying to establish is to see, can we use this as an inspiration? So what we know from the aviation industry, can we use it as an inspiration to look at comfort in more detail when it comes to shared and automated vehicles. And so what you see here is a translation and a reinterpretation of this model based from the aviation industry for future vehicles. So what the diagram here illustrates is that comfort and well-being is considered to be affected by 8 different factors. The size of the circle is indicative of the importance when it comes to the perception of comfort and well-being. At this point, this is still very much hypothetical, and we're working our way slowly through this model, trying to understand what the different elements, what their relative importance are in terms of the comfort perception. But probably not many people would disagree that peace of mind is a very important factor when it comes to comfort and well-being. There's a lot of attention and effort being put into trying to understand the aspect of trust. The HMI plays a very important role in this, bridging the gap between the machine and the occupant. Given that it's such a widely researched area, I won't delve into any more detail into this. But related to that is also, for example, the perception of safety, which has an impact on our peace of mind. How can we influence that, for example, by the design of the interior, but also the design of the HMI? The second aspect is the physical well-being. So that relates to noise, vibration, harshness, the thermal conditions, motion sickness, crash worthiness of the vehicle. So, for example, a lot of the proposed rearrangements of activities in future vehicles have big implications for passive safety systems, but also postural comfort. Again, with future vehicles, we anticipate that we have different postures, different activities, and so they will have an impact on our physical well-being. Proxemics is a term that you may not have heard of. It's typically used in the context of interpersonal distances. Here in this context, it's mainly referring to a sense of autonomy within the vehicle, a sense of control and a sense of privacy, which has been found to be very important in the aviation context. And we can imagine that this will also be very important, particularly in the shared vehicle environment. Usability, a very obvious one, a traditional car HMI issue. Affectability, controllability, ease of use, accessibility. These are all aspects that will have an impact on our overall sense of comfort, particularly if we think that we'll be using our time interacting with displays, for example. Again, given the challenges that we have in terms of designing for a moving environment, trying to create content rather than just consume content, the usability of future HMIs are very challenging, as I'm sure you are aware of. So pleasure can have a big influence on our comfort and well-being. We see a lot of concepts that create new sort of user experiences, that create new stimulations, etc. This is great, but what we very often see is that these new sort of experiences are designed not necessarily keeping in mind some of the human factors principles in terms of, for example, in terms of comfort. There's a social element. This relates to how we interact with other people within the vehicle, but also might relate to the connectivity available within the car. There's an aesthetic element. Aesthetics is quite an interesting one in terms of comfort and well-being. So it refers to our sensory interaction with the vehicle. But also aesthetics is a good example where we can see these different factors that might have an impact on comfort actually start to interact. So, for example, we know that aesthetically looking interfaces are considered more usable. We also know that there's an interaction between aesthetics and the level of trust that we have within the system. So you can see that aesthetics has an important role, but we don't quite yet understand the relationships between the different factors yet. Finally, there's also the association that we have with a certain environment and certain interior slash HMI. Okay, so as you can imagine, this is quite a vast topic. The way we are looking at using this model is actually to try to get to grips with the different elements that we need to think about when we talk about comfort and well-being. And we use it as a research guide to sort of separate some of the different areas that we're looking into, but also as a design tool. So, for example, we've been designing a low-speed autonomous part of first and last mile mobility solution, where we use this framework to actually make sure that, from the design perspective, we incorporated different elements that are of importance when it comes to the design of the vehicle, both the exterior and interior, and of course also the HMI. Okay, so what I would like to focusing on for the rest of the presentation as a way of as a sort of a case study for comfort and well-being and the role of the HMI is a topic that I've been working on for quite a while, illustrated by this rather unpleasant image, and that's motion sickness. So it's taken a while, but I think the automotive industry is now realizing that motion sickness is actually a big problem when it comes to future vehicles, and it's now even being positioned as a very critical element that we need to understand to be able to actually realize the potential of future vehicles. It's needless to say, if people experience motion sickness, they won't be able to, they won't accept these vehicles, and all the benefits that we might gain in terms of more enjoyable, meaningful experiences while traveling, or more productive experiences, may not come true if we actually experience negative side effects such as motion sickness. Okay, so if we think about motion sickness and car sickness in particular, it's important to understand a little bit about the fundamentals about why we get sick in the first place. The first reason is any exposure to low frequency motion renders us susceptible to motion sickness. And there's an evolutionary reason for this, which I won't delve into now, but typically what we see is that, for example, aboard a ship, it's the very low frequency motion around 0.2 Hertz where people get sick. Any frequencies that are above or below that tend to be less provocative. And what you can see there on the right as well, another element is, which you may have experienced yourself, if we are below deck and we are moving with the boat on the sea, there is a discrepancy between what we sense with our visual system, our eyes, and what we sense with our vestibular system, or our organs of balance. So our organs of balance would tell us the correct motion in that we are moving with the ship. But from our visual perception point of view, we see a stationary environment. And so what this means really is that there's a discrepancy between the expected motion and the sensed motion. And this is a very important aspect, because a similar thing happens actually when we're in a automated vehicle or a conventional vehicle and we're reading a book. So what we see with our eyes is will tell us that we're in a stationary environment, but the actual vehicle may be moving, and so we've got a discrepancy between these two senses. So very briefly, when it comes to low frequency motion, this is particularly relevant for longitudinal motion, stop-start traffic, We may have lateral motion with cornering, winding roads. And depending on suspension levels, we may also have some low frequency motion in the vertical axis and the z-axis, which, as I mentioned already, is largely a suspension aspect. So when it comes to shared and automated vehicles, there's some very fundamental aspects and fundamental use cases that will actually lead to an increase in the likelihood of motion sickness happening. So the very first one that I already briefly mentioned is the absence of vehicle control. So we know that pilots and drivers are less susceptible to motion sickness compared to the passengers. And the reason for this is that they can anticipate the future motion trajectory of the vehicle actually quite accurately. A second aspect is the engagement in non-driving tasks. So here you can see the example of reading. Here there will be a discrepancy between what we are perceiving with our vestibular and proprioceptive system compared to the stationary environment that we see with our eyes. Finally, the suggestion that we have alternative seating arrangements where we might be traveling backwards. Again, it will be very difficult to anticipate the future motion, so we don't know what motion to expect, and there may be a difference between what we expect and sense, and hence we may experience motion sickness. So some very fundamental guidelines to prevent motion sickness then is to avoid, first of all, these low frequency motions, but also to allow occupants to anticipate the vehicle's motion trajectory. So, for example, in some of the examples that we've seen of the concepts is that we have very small windows or very little opportunity to look out of the window, or it may be blocked by displays located inside of the vehicle. And again, this doesn't allow us to anticipate where the vehicle's going, where we're going, and for that reason might lead to motion sickness. Finally, we need to avoid sensory conflict, so incongruent visual, vestibular, self-motion cues. So here again, we see an example of someone reading a book inside a vehicle. The vehicle might be moving, we might be feeling these movements, but it doesn't correspond to the motion that we see from our vision. So just to give you a few case studies of how important this is and also how this relates to the HMI design, I'd like to present a few studies here. What you see here is a study that we've done last year, where we were interested in understanding the impact of having a head-up versus a head-down display. So in a lot of concepts, we've seen head-down displays buried quite deep into the interior. And from a theoretical point of view, we would expect this to lead to an increase in motion sickness. And in fact, some work that I've done previously already sort of indicated that there's a big difference depending on the position of the display. In this study, we see a very highly controlled experiment in which people were asked to either use a head-down or head-up display, conducting a visual search task while being driven along a slalom route. So each condition was experienced by 15 minutes, and of course a big difference between the head down versus the head up display position is that the amount of peripheral vision that the user has in the head up display condition in particular. So based on this, and as we expected, there's a big difference in terms of the expected in terms of the experienced motion sickness levels. And what we can see here is that head-up displays lead to considerably less motion sickness than head-down displays. Again, this relates to the fact that we can use peripheral vision to sample the environment to have a better sense about the actual motion that we're feeling with our vestibular system and what we expect to feel based on our visual system. So what the direct design implications for this is that where possible, we need to position displays that allow occupants to see the outside world. So in other words, head-down displays buried deep into the inside of the vehicle are not recommended. There's various outstanding research questions, for example, the display size, so how much peripheral vision is actually required, the location of the display, so this relates to which part of the visual field is particularly important, so which part, how peripheral, the amount of information contained in the visual field depends on the peripheral level that we're looking at, And so understanding where the most valuable information is provided is useful to understand. We can think about see-through and AR type of displays. In fact, there's been some studies done using see-through displays which show a decrease in the level of motion sickness. Related questions to this are, of course, how effective they are, but also more importantly, probably how acceptable they are from a usability point of view. So how readable is text, context, etc., content in these sort of see-through displays. Another aspect to consider is the display content. So, for example, this study was done with a highly visually demanding task, but we know that there's differences. For example, if we look at video, where there's an auditory element to it as well. And what this allows people to do is to really take their attention away from the visual display and sample the environment. And this also means that people have a better sense of their own motion in the environment, which may reduce the level of motion sickness to some extent. And finally, self-management motion sickness. So how do people cope with this? We can think about designing HMI solutions that allow people to take a more sort of active approach in trying to reduce motion sickness themselves. And one thing to keep in mind, which I haven't mentioned yet, is actually that the level of susceptibility of motion sickness varies dramatically between different people. So finding a general universal solution for all people is going to be probably quite difficult. And so adaptable and personalized solutions may be more appropriate. Okay, so in the light of this study, I'd like you to have a quick look at this video and particularly focus on the co-driver. Oh, sorry, that video is, here we go. No, sorry, the video's not working. Never mind. What I wanted to show you is a small video of a rally, and as you may be aware, there's always a co-driver in rally, and throughout rally, the co-driver is constantly looking down to his or her notes, which are called pace notes. So again, looking back at the study that's just been presenting, you would expect that these co-pilots experience quite a lot of motion sickness during these rallies, but actually, as it happens, this is not the case. So it's surprising, like that the level of motion sickness in these rallies is actually much lower compared to the reconnaissance drives in preparation of the rallies. And so the authors of this particular study argued that the pace notes that the co-driver has actually allows the co-pilots to anticipate the oncoming motion. And again, when we think back about what causes motion sickness, is this difference between the sense and expected motion. And so the argument here is that by having these nodes, it allows the individual to actually anticipate the upcoming motion and therefore experience less motion sickness. Now, this is an interesting concept, and actually has been shown to work in other environments as well. So here we see a flight simulator in which people are being exposed to turbulation, air turbulence in a simulator. And inside the cabin, they were either shown Earth fixed reference points, which are the stars dotted around, and in addition, also a sort of roller coaster track indicating the future motion of the vehicle. And what's really interesting here is that this led to a 4-fold reduction in the level of motion sickness, which is quite dramatic. And so the next sort of logical question is to understand, can we adopt a similar approach in a road vehicle? And in fact, a study conducted a while ago by we.CONECT, in which contact analog display was used to initially to increase the level of trust and situational awareness. We can imagine that this may also have an impact on the level of motion sickness. And another related aspect is that actually this sort of approach is already being used by chauffeurs of limousines, for example. So this is called the forewarning principles, where chauffeur informs the passenger of oncoming maneuvers. And this may be done in different ways. So this might be done verbally by informing, oh, sorry, we're about to take a corner, etc., or actually by very, very subtly changing the vehicle dynamics of the vehicle by either have a slightly braking or providing a slight steering input just to warn the rear seat passenger that something is coming up. recent passenger might respond to that by looking up out of his nose, and therefore feel more comfortable by doing so. So there's some indication that this sort of anticipation has a beneficial effect, and we conducted a little study to actually sort of as a proof of concept, really, to understand, does it actually work, and if it works, how well does it work? And so in this study, we had participants driving around a city circuit on the test track, and again, were asked to engage in a visual search task, which was presented in a head-down display. We measured all sorts of things, but for now, really the important thing to keep in mind is that in one condition, people didn't receive any auditory motion cues, whereas in the other condition, people did receive motion cues, and these motion cues consisted of spoken words indicating the upcoming maneuver of the vehicle. So, for example, there's a right-hand turn ahead. And these are presented approximately 3 seconds ahead of the actual vehicle maneuver. So let's see whether this video, I'll get this video to work. No, I'm afraid not. But yeah, again, here you can see in the sort of experimental setup of what we've done. What we found, okay, the video is now working.
Right-hand corner ahead.
So there you just heard one of the cues that were being presented. So very first of all, it's very important to remember that in this condition, so we're looking at sort of urban driving situations, almost all of the participants actually reported motion sickness within literally minutes of conducting this trial. And again, this was a quite heavily visually demanding task with a head-down display, but a lot of participants were actually surprised how provocative it was, and it just indicates how powerful an environment it can be and how important it is to get the HMI right. So 50% of our participants had to terminate the trial prematurely due to the severity of the symptoms. We even had some participants vomiting. Luckily, we managed to do that outside of the car. Here the point as well is that here we can see the sort of the build-up of motion sickness over time in the queuing versus the no queuing condition. And so in the left graph, you can see that motion sickness gradually increases over time. But also that you see there is a shift between those two conditions. So in the no queuing condition, the solid line, we can see that it's slightly higher compared to the queuing condition. And so these effects were found to be significant. And what it does suggest is that the motion queuing has a beneficial effect on the level of motion sickness. So they do work. They are not a silver bullet, however. And one of the really challenges is that they were being perceived as cognitively very demanding and annoying. So the challenge here from a HMI perspective really is to design these type of solutions in an effective but yet acceptable way. And I think that's one of the main challenges. So in terms of outstanding questions related to this, there's questions around the timing of providing these cues, how specific this information should be, whether other modalities are more appropriate or more suitable or more effective, or whether perhaps we should look into multimodal perception, multimodal stimulation, and finally, very important, is about user acceptance and how they integrate with other activities that people may engage in while driving around in the vehicle. Okay, final example that I briefly want to talk about, I'll go through a little bit quicker, is related to alternative seating arrangements. We've seen many concepts where we have forward versus rearward seating arrangements. And of course, the idea behind this is that it becomes easier to interact with our fellow passengers in the vehicles and create a more social environment. However, as we already seen from a motion sickness perspective, we can expect this to lead to more motion sickness. So we conducted a study with a modified van in which we have forward versus rearward facing passengers, which you can see illustrated here. And again, 2 urban drives, 30 minutes each, in which people were asked to engage in typical office-based activities like checking the laptop, writing notes, having conversations, etc. And so what we found here is that, first of all, urban driving leads to far more motion sickness than motorway driving, which is something we would expect given the different motion profiles. But if we're traveling rearwards, there was a 5-fold increase in the level of motion sickness experienced, and this was true for all of the participants that actually traveled backwards. So what this means is that from a motion sickness perspective, it's definitely not advisable to include rearward-facing seating arrangements. So in terms of the HMI, this does raise a few questions in terms of if we do want to have rearward-facing environments, can we somehow augment the environment perhaps to compensate for the lack of outside view and also our ability to anticipate future motion? So can we, for example, include ambient displays that may be located in the periphery, in the interior, in the for example, doors of the vehicle to provide additional information with regards to motion. We can then also look at what the effects are of different sensory modalities in this. Is the visual modality the most appropriate ones? Can we use sound? Can we use haptics? There's all sort of different aspects that we can consider. And again, coming back to the acceptance, it's very important that we keep in mind that this has to be integrated with other things that people may be doing, which again is quite a challenge. And finally, we can also think about innovative seating and interior design that actually allows people to sort of self-manage these sort of challenges to the perception of comfort. And again, the HMI may be part of this. Okay, so to very much round it up, I'd like to provide you with a few sort of high-level HMI guidelines that are worth keeping in mind in this context. Obviously, it's about avoiding incongruent motion information and also allowing people to anticipate future motion trajectories. So when we talk about display position, they need to be located near the line of sight so that people are able to look outside of the vehicle. Display size will also have an impact. So there's two elements to it. Larger displays may induce motion sickness themselves by providing a very strong visual cues. The display size may also block the view of the outside world, and again reduce the ability to anticipate the future motion path. Finally, the display content I think is very important. Dynamic content might create problems by themselves. Highly visually demanding content might be very provocative, and it may be better to consider multimodal content. An example that I've provided before is related to the auditory video example. Finally, we may be able to provide or use the HMI to provide additional visual information to compensate somehow for some of these conditions, whether they're related to rearward seating, facing arrangements, or lack of ability to look out of the window due to the interior design. And finally, we may use see-through or augmented reality displays to compensate for some of these problems, and this may prove to be a viable solution as well. Okay, so coming back to the comfort model, as you can see, this was a very brief overview of some of the aspects that are important, and what I homed into was one very specific aspect, which is related to motion sickness and the design of the HMI. As you can imagine, there's a whole raft of other issues and questions related to comfort and well-being and how that might be related to the HMI. I don't have the time now to talk about this, but I'm more than happy if you're interested to have further conversations around this. Please get in touch, and I'm happy to do so. Very finally, we are working on a joint industry project. We are developing a mathematical model to allow designers and engineers to predict the level of motion sickness depending on their design choices. This has already started, but there is still an opportunity to join the project. So I'll just quickly throw this in if anyone would be interested. Again, please get in touch. And with that, I'd like to thank you very much.
Thank you very much, Cyril, for your presentation, for giving us really deep insights into the topic. I think with this, I would pass over to Leonie, and we are ready to start with the Q&A.
Yes, thank you. Hello, everyone. Welcome to our little Q&A session now. To everyone, make use of the time and send in your questions if there are any more, and we'll get started right away with the first that have already come in. So you spoke about the aspect of comfort in the design of the autonomous vehicles, but can you maybe just explain to what extent this factor is different in the design of autonomous vehicles rather than standard or non-automated vehicles?
Yeah, so it's a very good question. So of course, if we, and you've seen it in some of the examples of the studies, we are in a way simulating automated vehicles by putting a passenger in the passenger side. And so in many ways, it's not different from being a passenger in conventional vehicles. However, what's different is and this is coming back to the user expectations. So as a passenger in a conventional vehicle, we do not expect to be able to engage in all sort of non-driving related tasks. So for example, if you travel around and you look at what people are actually doing who are on the passenger side of things, they typically look out of the window and do nothing or have a conversation with the driver. So the whole premise of automation in particularly is that we are going to be using our time more effectively or more enjoyable by engaging in these non-driving related tasks. And particularly if we're looking at some of the concepts that have been provided, this very often includes some sort of interaction with a display. And so it's not so much the difference between a conventional vehicle and an automated vehicle, it's more the difference between how we think we will be using our travel time.
Okay, that is really interesting. So there'll be more sort of people will be engaged in different activities or more making use of the time in the automated vehicle with reading or other activities that could then sort of increase the need for more comfort and well-being in the ride.
Yeah,
that is very interesting.
It's very much the premise of automation. Yeah.
Yes. So then regarding these 8 points of comfort and well-being, you said now the most important ones are peace of mind and physical well-being. Do you see these changing in the future, that maybe other factors come in or become more important long term?
I think what might happen is the way I think the importance could be considered as a sort of a priority of making sure that we understand these and get these right first. So I think things like trust, physical comfort, like motion sickness, the usability of the environment and the interfaces, I think these are sort of must-have attributes, and some of them are sort of hygiene aspects. So we need to get these right for the technology and these future vehicles to be accepted in the first place. And so they are a priority before we can even start thinking about some of the other comfort factors that will also be of importance, but probably not as critical.
And how do you think these comfort considerations will change in cases for sleeping rather than activities?
Yeah, so sleeping is of course is very different. So a lot, of course, you're being excluded from the environment in many ways if you're sleeping. So a lot of these things become less relevant. I think with sleeping, the main consideration at the moment really is the safety aspect. And as you can imagine.
Good. Then we have 2 more questions that go in regard the motion sickness studies that you've done. So are there other factors such as the speed of the vehicle or the vehicle environment, sort of urban or non-urban, that play a role in the level of experienced motion sickness?
Yeah, so the vehicle dynamics is one of the most important factors. So the way to think about it is that our vestibular system are basically biological accelerometers. So what we sense are only accelerations. So if we're accelerating at a constant rate, we stop, our sense of motion stops, as in we don't feel ourselves accelerating anymore. Similarly, if we're traveling at a constant speed, we feel actually like we're in a stationary environment. which explains that if you're sitting, for example, in an airplane, you don't feel like you're moving, you feel like you're stationary. So this is really, really relevant, because if we look at, for example, motorway or highway scenarios where we have a free-flowing traffic and we may be traveling at pretty much constant speed, then that will allow us to do all sorts of things, because our vestibular system tells us we're stationary. And so any sort of interaction with stationary interfaces doesn't necessarily lead to motion sickness, because they're congruent motion cues. In an urban environment, it's very different, because we're constantly being exposed to lateral and longitudinal accelerations. So the opportunities for conflicting motion cues are much larger.
And do you think that this factor of motion sickness might be an obstacle to fully implementing autonomy level 5?
So it's actually,
so could that be a hindrance to implementing level 5 vehicles?
Yeah, so I think this comes back to the user expectations. So if we expect to use our time more enjoyable or more productive, then and engage in sort of in-vehicle activities that might involve displays, etc., then I think this will be a problem, and it will reduce the acceptance of the technology as such, because again, this is coming back to the very first argument. I think the major benefit from a user perspective is to use our time more meaningful.
Okay, there was one more question regarding this motion sickness studies. Just sort of, with how many participants did you do these studies?
Yeah, so most motion sickness studies tend to use a within subjects design, and we typically use between 12 and 16 participants for these studies, which is a conventional number of participants for these studies to have sufficient power to show difference between conditions.
Good, and maybe the last question for our Q&A session is, can you define and measure peace of mind?
No, well, peace of mind is of course, it's a very, very large concept, but I think there's different elements to it. It's made up of different elements, and so system trust is one of the elements in there, and I think it's like everyone agrees probably with, it's a very basic element of peace of mind. But there's other things like the perception of safety. So again, this is related to how safe do we feel in the environment that we are, and this might be related to the external environment as well, in terms of what are we surrounded by, and how does that compare to our perception of the vehicle that we are in. Again, we can think about providing people with assurance from an HMI perspective in terms of level of safety. But it also has a sort of interior design element in terms of how we can create this cocoon-like effect, for example. It's very multifaceted, and this is part of the problem with comfort, is that it has many different layers and elements to it.